Today I'm going to talk about Guerrilla RF's cable TV offering. So we have a lot of different amps. We have 3 single-ended amps right now, and geez, I can't even keep the count of the push-pulls that we've designed. We'll go through them. And I'll start with the single-ended 9461. It's designed to be in the same gain configuration as a lot of the competitors' parts that we're going up against, because a lot of the gain that we're offering is pretty much used in the system for the whole chain in different gain settings. So the 9461 is a 20 dB amplifier designed to have a slightly lower noise figure than what our competitors offer. Very good linearity. The way it's designed, it actually, as you increase power, you can actually get a little bit better output IP2 out of it. And it's basically operation from 50 to 1.8 to 2, well, is as far as the CATV system is 1.8 gigahertz, but you can operate it up to 2 gigahertz too. It's got very good performance out to 2. It is a 9123. This is GRF 9123. That is a slightly higher gain. It's not, the 9461 is pretty flat. The 9123 has a slight down tilt, but it was designed to be able to use in the systems that are using a specific competitor's part, but very low noise figure. It has slightly higher current, but it has much better linearity. So the noise figure is like around 1 dB, 1.1 at 1.8 gigahertz, which is extremely low for the industry. It's a 9460. So this is designed to be a very linear part, 17 dB gain part, and it's it's not a high gain, but it still has pretty low noise figure, or about 1.5, 1.6 dB at 50, and at 1.8 gigahertz, it's about maybe 2.1. But it was designed to have up tilt, and it's a part that goes all the way out to 3 gigahertz. So the systems are always increasing in frequency. I know there's 3 gigahertz out in the horizon out there, so I wanted to be able to have part that we could actually offer out to 3. So we're having very good linearity all the way out to 3. Good IP2s. They're all DFN8s. And that was specifically chosen to be able to have a very small, easy, and good package for the power consumption. I know a lot of the industry uses SOD 89, but in my experience, those packages, the lead frames are good lead frames are hard to come by, and they have quality issues. So it was specifically designed to be in a DFN8, so it could avoid all that and be easily used by the customers. 50 ohm and 75 ohm the same, just different matching components, values basically. In a 50 ohm, well, I'll start with 75. So on the 75 ohm, a single-ended board, you would see a DC feed inductor, and that can change. I mean, that it depends on the customer preference. We've chosen a few. We've chosen an 0603 that seemed to have good performance because it's smaller. And then input and output matching. So you see DC block caps and input and output, and you would see like series inductors and maybe a shunt capacitor on the output or input or both. So not a whole lot of components. So worst case for a single-ended part, you're talking 7 components, 8 including a bypass cap on the feed inductor. The choke type is critical. You want it to be able to have not a whole lot of Q on it. You want it to be broadband. You want it to be broadband capable. So you want to avoid resonances in the band. So I've used ferrites, but I've used more ferrite core inductors. So if the inductors with ferrite cores tend to be a lot less Q, more broadband. So there you don't have the real peak resonances that you would have with higher Q inductors at higher frequencies. Depends on what feed inductor you use. So on some of the parts that we have, we're big value on the input and maybe 120 picofarad on the output to be able to match the lower end. So be able to better match at 50 megahertz. That changes though, depending on what kind of a feed inductor you would have, but what we use, that's the circuit we would use. We would use a big capacitor on the input and a smaller capacitor on the output to help with the matching. On the first parts, I would say that there's probably weaknesses with output P1 as you approach in the higher frequencies. And that has to do with some of the protection that we've chosen, but they're pretty good performance, and it's still good performance, about 23 dBm at 1800 megahertz. But the newer parts that we have, that's all corrected.
Thank you so much for watching. If you'd like more information, please email us at sales@guerrilla-rf.com. And don't forget to subscribe to our channel for more content from Guerrilla RF.